right, so we're going to do example 1 of finding the area inside a polar curve. And yeah, so we're given the polar curve r of theta equals 1 plus cosine theta, and it gives you the bounds from 0 to pi, right? And you could plot this if you want. I already have plotted it here, and it's a calculator okay section, so that's fine. Most of the time when you're asked to do area of a polar curve, it is either going to be a calculator section, where you'll be typing in the work to find the numerical value in your calculator, or it's going to say set up but don't integrate. Sometimes you're asked to actually find this on your own by hand, and it's possible, but if that happens, it's going to be a situation where you're able to simplify the integrand in some way. It doesn't mean it's going to be super awesome and fun, but you'd be able to simplify the integrand in some way, probably using a trig identity, so I know you're cringing when I say that, but it is what it is. All right, so we're going to find the area bound by the polar curve given from 0 to pi. So we learned in the last video that the area inside a polar curve, right, that the area inside a polar curve should be the integral from the starting angle to the ending angle of 1/2 whatever my r is, so 1 plus cosine theta quantity squared with respect to theta, right? So that's your job there, is to set this up and be like, cool, awesome, that's where we're at, right? Now, as problems get more difficult, sometimes you're going to have to find the boundaries, but here I gave you the boundaries, so that's all you have to do. You now need to type this in your calculator to find an answer. One of the places that this gets annoying is that in polar mode, you can't do a lot of the stuff that you're used to doing. So in polar mode, it's a little bit harder, like you can't second calc 0, you can't do a lot of stuff that you might want to do. So you can put your calculator in polar mode, right? And you can put your R1 in here, as I've done here. Make sure you're in radian mode. And you can quit out of that, and you can type this in, right? You can type in that you want to do a 0.5, right? Because that's what I'd probably do with the 1/2. And then I would go ahead and do the function integrate of what I called R1 squared with respect to theta from 0 to pi. And that's totally fine, right? So you can still do that. You can still math 9. So I'm going to go ahead and hit math and 9, right? Oh, I forgot my 0.5, so I'm going to go back and second insert 0.5, right? I'm going to go to vars, I'm going to go to y-vars, and this time I'm going to go to polar and pick R1 squared, comma, with respect to theta, and I can use that independent variable button because in polar mode it'll be a theta, comma, from 0 to pi, right? 0 to pi. And then I hit enter, and I'll get an answer, and that's it. And it's totally fine. You can integrate in polar the same way that you normally would, and when you do that, you're going to get that your area is approximately 2.356, and that's what you want, right? That's the area that they asked for. But again, there are certain things that your calculator doesn't do as well in polar, like second calc 0 is a bit of a problem. There are things in polar that are not so much fun, so we're going to wait on that for a little bit, but sometimes it's worth doing this in function mode instead.